Hello there and welcome to this course on data analysis for healthcare with Python. My name is Valentine and I'll be your instructor. In this course, we'll follow this structure. We'll start by learning the learning outcomes, which are just generally goals of this learning experience. Then after that, we'll talk about what those data analysis for healthcare with Python concepts are. Then we'll also talk about why we perform those data analysis concepts. After that, we'll go through a practice session where we will practice those concepts using the Python programming language. We'll provide examples as well as challenges that will allow you to acquire the skills that we'll have set out to acquire. Then towards the very end, we just talk about the next steps, which will just be what then comes after this particular course. So let's get started. By the end of today, we expected to have achieved these learning objectives or learning outcomes. We should be able to perform ranking while selecting records in a data set. We should be able to filter for records from a data set through the use of conditions. We should be able to perform sorting in ascending or descending order. While selecting records from a dataset, we should also be able to perform descriptive analysis using aggregate functions. And lastly, we should be able to create summary tables using the group by and pivot table functions. Our major focus will be on these learning outcomes. Again, if there are other data analysis concepts that you might have in mind that are not included, just know that that is not what we're going to be covering. We're just going to focus majorly on these concepts, but hopefully in some future sessions, which you can actually provide us feedback with in the comment section on that kind of an interest that you might have. So starting off, what is data analysis for healthcare with Python? This just entails the process of using the Python programming language and also its various libraries to be able to analyze as well as derive insights from healthcare data. So it might mean being able to import data into an environment that you're going to be working on with regards to the project. You import that data from different data sources. Then you explore the data, you filter the data, you select maybe columns that are relevant to your analysis, as well as also perform other arithmetic operations such as using aggregate functions, maybe to calculate the average or mean of a particular variable of interest that you might have. So data analysis for healthcare with Python generally entails that. With regards to Python, Python is a popular, versatile programming language. It's a programming language that we can use in different contexts, and we can use it to perform data analysis work. So that might mean maybe creating a dashboard. It might mean just doing generally data analysis reports, creating data analysis reports based off historical data that an organization has collected, etc. And the reason why we would want to use Python over other languages in data analysis, you could use R, you could use other tools as well, not just Python, maybe tools like Stata or even Power BI for visualization. But the reason why we would want to use Python is because it has a rich ecosystem of libraries that enable us to perform data analysis work and also be able to have the ability to take advantage of machine learning libraries if at some point our project requires us to implement those concepts. When it comes to learning, Python is an easy language to pick up. So if someone wants to join a team that works with Python, then it's quite easy for them to be able to do that. Community support, if you have questions, if you come across issues that are maybe specific to your project, it's highly likely that you'll find other persons who have also come across such issues and have posted also solutions on how to go about those issues online. Cross-platform, you can use it across different platforms, as well as you can integrate it. You can use it with other different tools, not just Python related tools, but you could also use it maybe for for retrieval of data with maybe a tool like Power BI, or you could use it with another tool, maybe some web application somewhere that has been written in another language. You can still be able to integrate Python somehow with those particular tools. This is because generally Python has a lot of developers who've created extensions or plugins for those different tools. In terms of data analysis, generally, I've talked about data analysis from a descriptive perspective. So from a perspective where we look at past data and we try to analyze, understand what has happened and provide some sort of analysis or recommendations or just insights. So that type of analysis is called descriptive data analysis. There are other types of analysis that we won't focus in this session, but in other workshops related to machine learning. These include diagnostic data analysis, which is a type of analysis that aims to determine why something happened. So you might want to determine why does this particular variable increase or decrease within a certain system. So that's a type of analysis that you could do. You could perform what are called experiments, and that relates to experiment research design, and undertake actually those experiments to understand why maybe that variable behaves the way it behaves. There is predictive data analysis that involves creating what are called machine learning models to predict the values of a variable based on some historical data that that model has been trained on. There's also prescriptive data analysis that involves the three different types of analysis. Our focus will be on descriptive data analysis, which it's more of an introductory type of analysis that will be important. Even when you're working on these other types of analysis, you're highly likely to perform descriptive data analysis in order to understand the data that you're working with. Maybe training data for predictive data analysis models. So you might want to first of all explore that data, and also maybe create even visualizations as a result of just descriptive data analysis. So descriptive data analysis comes in handy in so many different contexts. Why would we want to perform data analysis for healthcare? There are various reasons. These are just some of the most important reasons that we thought would be important. So the end goal might be to improve patient care. So you might have some patient data set and you would want to identify patterns, or even just create machine learning models or predictive models that are able to predict disease progression, whether there are cases of a particular disease, the cases of particular diseases will rise or depreciate over time. And you could also personalize treatment plans based again on just data pertaining to patients. Disease prevention and early detection is another goal that one might have when it comes to performing data analysis. And as a result of analyzing data and determining just key insights from that data set, you might end up recommending some proactive interventions or preventative measures in order to ensure maybe some outbreak does not really significantly impact a certain population or not. There's healthcare resource optimization. That's if you're working with resources data, healthcare resources data, and in such a situation, you may be working with maybe hospital bed data or staff or equipment or medications, or even just stock related data. And in such a situation, you might end up being able to craft recommendations that would lead towards optimization of the use of those particular resources. Quality improvement and patient safety is also another area that would also come in handy. That would also be able to leverage data analysis concepts. These are just a few concepts just to give you some idea of why would we want to learn some of the concepts that we're going to be covering in this session. The types of deliverables that you might end up working with with relation to data analysis for healthcare with Python include being able to create data reports. You might have research questions or just one research question, and you might require to just do data analysis concepts, which would give you key insights that would help address the research problem that you have. And that whole process would actually be contained in a data report. You might end up just wanting to create just standalone data visualizations for just those reports, or for use in presentations if you want to drive maybe some sort of point, and you might realize that maybe it would help having some data, but again, data as it is may not necessarily be as impactful as it would be if it were on a visualization. So that is something that you can consider including, say, maybe static visualization or even dynamic visualizations or interactive visualizations, where users can be able to interact with the visualization that you might want to create that would be relevant. Dashboards, in some situations, you might want to create maybe dashboards which would contain a collection of related charts, as well as other visual elements that would help inform stakeholders understand possibly the performance of an organization or performance of a team, or even just generally maybe when it comes to patient care data. You might have a dashboard that summarizes how patients are doing with regards to maybe recovery. So some key stakeholders might find that useful. Predictive models, you could do data analysis work at the very initial stages of interacting with your data in order to further prepare later that data for analysis. Data pipelines, maybe if you're a data engineer, if you ever want to become maybe a data engineer working with data, working in the healthcare sector, then data engineers build pipelines, and some of the concepts like maybe summarizing maybe a larger table that's with regards to group by would come in handy. And in other situations, maybe you might also want to learn maybe how to deploy some applications in relation to data analysis or in relation to healthcare, and that might lead you to just create maybe web applications or APIs. Again, behind the scenes data analysis concepts would come in handy. So these are the concepts in relation to data analysis for healthcare with Python that we're going to be covering: data importation, exploration, selecting columns, filtering, sorting, aggregate functions, as well as grouping, that we will cover in this particular workshop on this particular course. So at this particular point, I would want to ask you to visit the resource link that we've shared in the description section of this particular video. Just click on that link and it should take you to this particular notebook that you see on this page. So once you've clicked on the resource link in the description section for this video, just it will take you to this particular page, and you'll end up having now a notebook, which generally is a document that we use as data analysts to perform analysis on and be able to share it with other stakeholders for further analysis. So the first thing that we're going to do, by the way, if you just observe the notebook, it has different sections which cover the concepts that we've mentioned. And if you expand, you'll see that there are just different contents in regards to the section pertaining to that particular concept. So we'll go through each and every concept, and I'll also be sharing with you the work. I'll also be sharing with you the challenge that you need to cover. So that is something that you get to pause the video and do. So as we go through each and every section, I'll take you through the examples, and then I'll let you work on the challenge. And at that point, you can pause the video because this is a live stream. Work on the challenge, and once you're good to go, then you can continue to the next section, and you can unpause the video. So get to this particular page. Once you get here, just go to File, then Save a Copy in Drive. To save this copy in Drive, that way you are able to have your own copy in your Google Drive that you can modify and do other things to. So once you have done that, click on connect. Once it has opened a new copy in your new tab, you can close the original copy, this one that I have. Just work with the one that now has a copy. You can rename it at the very top by clicking this section and changing to whatever name that you want. Then you can click on connect and it's going to show connected, and then connect. Again, you can pause the video if I'm too fast and go back, rewind. So once you have done that, the next thing that we are going to do is to now go through the different sections. The first thing that we need to do is to import the pandas library. This is a Python library that we use for data manipulation or even just doing data analysis work. So let's import this library. So we click on this icon. If you get this particular warning, it means that this notebook was not saved as a copy. So you get this particular icon. That means you don't want to save any changes. If you close the window, everything that you have done will disappear, including the challenges in terms of the work that you do. But if you want to save this notebook for maybe future reference, you can save a copy in Drive. But I'll just run anyway because I don't need to save mine. So you should see a check. That should be good. So once you're done with that, then the next thing that we need to do, importing data. Let's start going through now the different sections. You can expand that and expand that again. So let me just hide the challenge. So starting off, let me see if I can even just, okay, I can't, I wanted to hide all the challenges, but it's okay. Starting off, the first concept, importing data from a CSV file. Sometimes you might want to import data that, healthcare data that we have stored in a tabular data or in a CSV file. And we would want to import it into this notebook and be able to do analysis on. So we can do that using pandas, and how we do that is we reference pandas. We already imported it as PD. So in any case where we see PD, we would be referencing pandas. So pd.read CSV. We run this, and we should be able to import this. So our data set is located here. And then in this link, then in quotes, and we store it in DF, and then we display it, as you can see here. So this is just some healthcare data set, and you can see what we have. So moving on, so you can just go through this particular explanation if you feel like we have maybe left out something. Yeah. So the next thing you're going to do is to work on the challenge. So we've shared a challenge. Just learn from the example that we have given here. Try to see what's happening. You can even copy the code and then paste it in the challenge and then work towards that. And then once you're done, then we can continue. So you can pause the video, work on the challenge. Then once you're done, we can continue. All right, so for the challenge, this is the solution. So this is what we have. So we are reading the CSV file from this URL, and this is what we have. And we are storing it in DF and printing out the data from DF. So yeah, so that's what we have. Just be careful. You can always just copy the link address and then paste it here, or you can just copy what you have here and paste it here. All right, moving on, data exploration. Sometimes we might want to, not even sometimes, once we have imported the data set, we would want to explore it. And we cannot just display the entire data set if it has 1 million records. We might want to just use some different strategies. So initially, we might want to get the first 5 records to just get an understanding of the structure of the data set, so the column names. So how do we do that? So we can do that by simply going through getting the first 5 records. So how do we do that? So once we have imported our data set, this is how we import our data set, just as we did previously. Now this is a new data set, by the way. In every instance, we'll be having just new data sets before just for diverse, so that you understand just how we can just work with different data sets. So we've imported this data set, it's a different data set, and stored it in DF, and then we can get the first 5 records using the head function, as you can see here. Then we run that, and we should be able to see now the first 5 records. And we can also get maybe 3 records if I put a 3 in between head, I should be able to get maybe 3. Now in our case, I'll get 3, just 3 records. So head just gets the first records, but now by default, as it is, it gets 5, but you can define how many you would want. Moving on, we might want to also maybe get the last 5 records, but we'll get to see that. At this particular point, work on the challenge that we've given you. So work on this challenge. Once you're done, we can continue. So this is the solution. So for the challenge, so you can see here, we import, then we get the first 5 records. So we've imported this record, this data set. All right. Moving on, getting the last 5 records, we might want to get the last 5 records. Maybe just zoom in a bit. Yeah, so we might want to get the last 5 records, and we do that using the tail function. So we used the head function here for the first. The tail would get us the last 5, but we can also do the same thing. We can define maybe want to only get the last 3 by putting a 3. Passing 3 as an argument to this function. So let's run that. And you can see what we get. The last 5, 10, 9. So the data set has 10 records generally. All right, work on the challenge. Pause the video, and once you're done, we can continue. So this is the solution to the challenge. Okay, so let's continue. So getting a random sample. So sometimes you might want to get a representative sample instead of getting the first 5 or the last 5, which might be sort of not what the entire data set has. We might want to get just a random sample. So how do we do that? We do that using the the sample function. So instead of head or tail, we use a sample function. So in our case over here, oops, sorry, I need to hide the challenge. I should have hid all the challenges. Sorry for that. You can see here, we are using the sample function, just like the way we did with the head and tail. And then we pass 5 to that particular function, and we get 5, and that's what we're going to print. Random sample, 5 records, which we are going to get. But you won't get the same number or the same records as I'm getting. Every time you rerun, you get just different records. All right, pause the video and then work on the challenge. This is the solution to the challenge. All right, let's continue. Getting the size of the data set. Sometimes we might want to get the size of a data set. So for instance, we might want to we have a data set, we've imported it, but we don't know how big it is, how many columns, how many records it has. So to be able to do that, we usually use what is called the shape property, which is what you will see here. So initially here, we're going to just preview the first 5 records to just understand the structure, how the records, the columns. So this is what we have: medication, quantity, and price. But now we don't know how many of the records are here, but we can say we have 5 columns. But yes, we have 4 columns because we can count. But if there were many 100, we wouldn't find it easy. We wouldn't be able to see it as easy. So we usually use the shape property. So by the way, for here, the reason why we even use the shape here, shape then square bracket 01, is because the shape property gives us 2 different figures. So if I change this, let me just change this to dot shape, I should be able to get 2 things. This is 10 and 4. This is a data structure. It's a way of storing data temporarily called a tuple or tuple. So we have the records here, and the columns here is 4. So records, columns. But to be able to get the records from this particular tuple, we usually just reference the first element from that tuple data structure using its position. The first element has a position 0. The second element has a position 1, as you can see here. So df.shape, then that's the number of rows, columns. 10 form. Right, at this particular point, pause the video, work on the challenge, and then once you've worked on the challenge, we can continue. Okay, so this is the solution. All right, so moving on, selecting columns. So we've learned a bit about data exploration. These are not visual techniques. Visual techniques would cover them in another session, another workshop. Could be in data visualization with Python, or even exploratory data analysis workshop, or even statistical data analysis workshop. So those are just concepts that we can execute quickly to just get an understanding of the data set that we're working with. So moving on, selecting columns. So we'll start off learning about how we can be able to select just one column, then later how to select multiple columns. Starting off, how do we select one column? So let's first of all load this data set and see its structure. So this is how the data set looks like. Patient ID, name, gender, age, gender, diagnosis, medication, admission date. And by the way, the data sets that we're using are all of them are just dummy data sets for learning. They don't have real information from actual patients. Yeah, just for clarity. So if we wanted to only work maybe with diagnosis, we can just reference the data frame itself, that's df, then we use square brackets, then inside we define a list of the columns. So another square bracket, then inside we have the column that we want to work with, so diagnosis. And we can actually store this in a variable if we wanted to, maybe diagnosis variable, that we could also do something like that, and also gnosis, and then print it out afterwards. That's also something that it works if you want to use that particular column later. So at this particular point, pause the video, work on the challenge, and then we can continue. All right, so this is the solution to the challenge. Okay, moving on, selecting multiple columns. So sometimes you might want to just select multiple columns, not just one column. So how do we do that? Let's first of all load this data set that we have here. We'll just load this data set. It's another data set, just diverse data sets that we have here. So this is what it has. To select multiple columns, it's almost similar to what we did here, only that we can define another column by simply putting a comma, then in quotes, either single or double, then we define the other column somewhere there. So maybe here we might want to just select name, age, diagnosis, we skip gender, and medication. So we do the same here. So here, just using a single column, single quotes. We can use double if we wanted to as well. Yeah, so let's run that, select multiple columns. So this is what we have. And then we can now use this somewhere else. We might even export it as a data set to do some other analysis, or to share it with other stakeholders, or even just to store it maybe somewhere else. If it's a data pipeline, we can store it in a database where other people can use, or where it can be retrieved maybe even by a web application that just that maybe doctors use, or other stakeholders. Right, at this particular point, pause the video and work on the challenge. Awesome, so this is the solution to the challenge. Right, moving on, filtering. So we've learned how to select the columns that we want, so we can also deselect in that way. With regards, we just choose the elements that we have, the columns that we have. So the next thing that we're going to learn is about filtering. So sometimes you might have 1,000 records, but only 100 out of those 1,000 records make sense for us to use. Like, maybe they pertain to a certain group of patients that we would want to just analyze further. So we can use filtering for that. So let's learn we'll learn how to filter using just one condition or using multiple conditions. By the way, we also have a course on data filtering, solely on data filtering with Python. You can always explore that in our channel and get to learn and get better at that. So let's first of all learn how to filter using one condition. So assuming that this is our data set that we're going to work with, so we're just going to run that to load it. A different data set, maybe it has just just insurance information. If we wanted to just filter the data set where the full insurance coverage is full, so we can do this. We can reference the data frame name df, then after that we can use df, so we reference the column that we want. That's the column that we want. Remember selecting columns, but now here we don't use double brackets, we just select the column that we want, that is insurance coverage is equals to full. So this actually is the expression that we would want or the condition that we would want to check for. For this particular case, we use equal to, and it's usually represented as double equal signs. If it's not equal to, we just put an exclamation that represents insurance coverage not equal to full, so which is the rest of the values, but we want it to be equal to. If it's a number, we would normally this would be a number. We wouldn't put quotes. Quotes is for any text that you have here, so it's for each, it would be just a number. And equal to, it would be like that. Or if it's less than would be the less than operator. Greater than 1, or we could say equal to or greater than equal to, it's less than or equal to 1 or greater than. So we would start with the greater than or equal to, a greater than or less than operator, if we want to look for to test those conditions. So if you want to use those conditions, but we'll just revert back to what I had. That was just for clarification further, if you just had those questions in mind. So that would allow you to filter for data sets that have, now in our case, full insurance coverage, for records with full insurance coverage, which you can see are here. All right, at this particular point, work on the challenge, and then once you're done, you can continue. This is the answer to the solution. No, not the challenge, the answer to the challenge, sorry. All right, so here we have now learned how to just work with one condition. What if we wanted to work with multiple conditions? How can we be able to do that? Let's first of all load this data set. Which we have. Then once we have loaded the data set and understood it, we can now learn how to work with multiple conditions. So here we had initially this is one condition. So if you had another condition, what we would do is we would enclose this condition in parentheses, and then left and right parentheses, that. So this would be in parentheses, and then we would add another condition, and we would use the ampersand sign. So we would use this ampersand sign, and then we would define now the next condition, which would be in the parentheses that we would want. So and this is and if we wanted to have multiple conditions, or if it was or, there usually, when we're working with multiple conditions, you can have and, where you want to have records where both conditions are satisfied, or in other cases, we just want just one of the conditions to be satisfied. In such a situation where it's usually or, we would use this operator. It's usually just a pipe operator for that matter, just a pipe operator for that, just that. But let me just go back to, where was I? Let me just go back here. So here we have defined our first condition where age is greater than 40 and diagnosis is equal to hypertension. So let me run this. You can see here, we're good to go here. All right, moving on. Let's work on the challenge, and then once we're done, we can continue to sorting. You can pause the video. Awesome. So this is the challenge to the solution to the challenge. Okay, sorting. We might want to maybe filter those records. Once we filtered them, we might want now then to work with this filtered data set and sort it in some way that we would want, maybe in ascending order. How do we do that? That's what we're going to learn. So let's first of all load this data set, this new data set, which we can see. This is how it looks. To sort now this data set, this is a DF. It's like, assuming we even wanted to sort filtered, we can also do the same thing, but we are going to just work with a fresh data set. So assuming we wanted to sort DF by age, so that the age values start maybe from the youngest to the oldest, we can do that using the sort values function. So we say df and then dot sort values, and then we say by, we use the parameter by equals to age. Age is the one that we want. We can also do the same thing with maybe another, maybe gender or diagnosis, and they'll be sorted alphabetically. Then we store those sorted values in df sorted, and then we preview them. We are previewing all of them actually. So you can see these are the records, and they start from 28, 32, 35, 42, incrementally up until 60. We can do the same thing, but let's first of all now work on the challenge, and then once we are done, we can continue to descending order. All right, this is the solution to the challenge. So once you've done the solution, the challenge, you can verify that from here. Awesome. So what if we wanted to sort in descending order? So not in ascending order, but in descending order. How would we be able to do that? Let's explore that. So let's run this cell to load this new data set, which we have here. And then we can sort the records in descending order. So we would use another parameter. So almost the same thing, but now we would define ascending and state that to equal to false. We could also use ascending and set it to true and also use it here. But by default, ascending is usually set to true, which of course in that situation, we wouldn't need to modify that. So in our case, we would set it as ascending equals to false, and that would sort our records by the admission date, and that's what we would end up getting. So we would actually end up sorting our data set based on the admission date. But let me see. Actually, we would need to do something else, which I haven't included here. We would need to convert this into what is called the date time. This doesn't give us the best. It doesn't work here actually for dates. It doesn't work, but we can do that by first of all converting this date column into a date time data structure. But we can try diagnosis. Let's try diagnosis and see how that works. What about patient ID? I think this works only for patient ID. So diagnosis actually works. It actually works because we start with P, like the letters that are higher alphabetically. We start and they are sorted from A, B, C, D, F, F, H, I, then P. It actually works. What doesn't work is admission. Admission doesn't work. Admission doesn't work because of that reason that I've shared. But we can also, let's try it, patient ID. And yes, this is also sorted likewise. But you can explore that later. So at this particular point, work on the challenge, and then once you're done, we can continue. Okay, so this is the solution for the challenge. Moving on, aggregate functions. So sometimes you might want to calculate averages or maybe maximum values, minimum values, summarizing data. So these are just some of the aggregate functions, and we're going to see how to work with them. Learning how to work with these might help later in maybe situations where you need to work with others or even just similar ones. So let's learn how to calculate averages with AVG, the average function. So how do we do that? Let's load this data set. So if we wanted to calculate the mean value of price, we can just apply the mean function to the column itself, df price. We get that 3.0. Awesome. In some other situations, we might want to do maybe maximum or count, but we'll see, let's say how we work with maximum. Let's first of all work on the challenge for mean, and then we can continue. Pause the video. Awesome. So this is a solution to the video and to the solution to the challenge for average. Almost similar. Okay, finding maximum values with max. So we might want to find the maximum values. So in some situations, we might want to just find the maximum values for age and maybe for weight, same case, and print them out. So we can, let's say, run this to be able to get the data set that we are going to work with, which is this one. Has age. We want maybe the maximum value of age, and store it in max age. So we apply just the max function, just as we did with the min function. So we can also do with min minimum if you wanted, like min if you wanted. But yeah, so that is something to work with. And then we print them out just here. Okay, pause the video, work on the challenge, and then we can continue. So this is the solution to the challenge, as you can see here. Awesome. For aggregate functions, we can also summarize data with count. So how do we do that? Let's run the first code to import data, and then we can just maybe count the number of patients by diagnosis. Maybe if you wanted to get how many patients had diabetes or asthma, we can use the value counts function for that. So and this will just give us, let's say, for each and every category that we have here, how many of those values do we have? So so hypertension 1, diabetes 1, etc. But for if we wanted to do maybe gender, we can also do gender. And you can see how many males and females we have in our data set. We have actually 10 patients. Okay, pause the video, then mark on the challenge, and then we can continue. So this is the solution. So this is the solution, as you can see here. All right, so let's continue. Grouping. So we might sometimes want to create a summary table from a bigger data set if we don't want to work with a bigger data set. How do we do that? We do what is called grouping, or we create pivot tables. So the outcome of this particular section, we can also use what is called the pivot table function for that. We have another course on data analysis, just on data analysis with Python, not really focused on healthcare. That would also allow you to learn more about pivot table functions. So yeah, so let's learn how to go about grouping. So we can group a column. We can group by one column, group a data set by one column, maybe by medication, and then apply some aggregate function. So maybe you might want to have medication, then have maybe quantity and sum. So let's first of all load this data set, and then we group by medication column and apply the aggregate sum function. So then once we have understood the data set, we can say group by medication, want to group this data set by medication, and then want to see the count of aspirin, how many they were, paracetamol. This is almost close to what we did earlier with count for the category, but now here we're just using a different way. So you can see the different medications as well as the quantity. All right, pause the video, work on the challenge, and then once you're done, we can continue. All right, so this is a solution to the challenge. Lastly, we can group by multiple columns, not just one column. If we wanted to group by multiple columns and aggregate, we can do that as well. So let's load this data set. And here we can define the columns you would want to group the data by, and then apply the aggregate function to the column that we want to apply to work with, and then we just say reset index to have a data frame format. So let's run this. You can see gender, diagnosis, age, and yeah, so that's what we have. All right, pause the video, work on the challenge, and once you're done, we can continue and wrap up the session. So this is the solution to the challenge. Reset index just ensures the data frame is the outcome is a data frame that we can later onwards apply pandas functions to. All right, so I hope you're able to practice the data analysis with Python concepts for healthcare that we set out towards achieving. So we were able to work towards the concepts that we mentioned earlier. So these are the concepts, and we share that on your screen. So these were the concepts: importation, exploration, selecting columns, filtering, sorting, aggregate functions, and grouping. These concepts will come in handy later if you maybe take data visualization work or you do machine learning work. They will come in handy. So yeah, I hope you are able to make the most out of the session. In terms of the next steps, you could always explore now data visualization workshops, more specifically one with Matplotlib or Seaborn, or even Plotly, or working with just statistical analysis concepts. Maybe if you wanted to create visualizations, maybe a histogram, a box plot to understand outliers, histogram just to understand the distribution of data in a variable, then you can do that. I hope you're able to learn and make the most out of this session. Hopefully we'll be able to see each other in the next learning experience. If you did love this video and you'd want us to keep on continuing creating more of such learning experiences, feel free to like this video so that other people can also be recommended, and also feel free to subscribe so that you're notified when we post such future courses. All the best in your learning journey, and see you in the next course.